Okay, this time we've been asked to determine the gradient of the lines which are parallel and perpendicular to the following linear equations. So we're only interested in the gradient of these lines. So remember, first thing is just looking and saying, well, what's the gradient of that line? The gradient of the first line is 2, because that's the x coefficient. So the line that's going to be parallel to that will have the same gradient. So the line parallel is just simply going to have a gradient of 2 as well. Now, if we're after the line that's perpendicular, the gradient of the line that's perpendicular to that line, then it's got to be the negative reciprocal of that, the gradient of that line. So the negative reciprocal means that we change the sign and we flip the fraction. Now you're probably looking and saying, well, 2 is a whole number, it's not a fraction. But if we write it as a fraction, it's actually 2 over 1. So if we flip that, then it becomes a half. But we've got to do the negative reciprocal, which means we change the sign, we'll change it to a negative. So the gradient of the line perpendicular to y equals 2x minus 7, or any line that has a gradient of 2, will be negative a half, or negative 1 over 2. So if we look at the second one, again we look at the gradient of the line that we've been given. Our m is negative 3/5, and that's the x coefficient. So the gradient that's parallel is just simply that same gradient, so 3/5. Now, if we're after the gradient that's perpendicular to that, again what we do is we find the negative reciprocal, so we simply flip the fraction and we change the sign. So it's simply going to be positive 5/3, and usually that's how we leave it, as an improper fraction, because it just makes it easier for us to graph it. Simply remembering that every time we go across by 3, a run of 3, we're going up by 5. Okay, so that's usually how we leave it. If you wanted to change it to, 1 2/3, you can, but it's not a requirement. Okay. Now, if we look at the last one, with this last one, again, we've kind of got it in general form. But what we want to do is change it to the gradient intercept form. So again, we look at it and we say, okay, we want to get y by itself on one side of the equation. What's happening to y? It's getting times by 5, then having 11x subtracted from it and 9 added to it. So let's start off by saying, well, 5y we can get by adding 11x to one side and subtracting 9 from both sides. So we're going to have 11x minus 9 is what 5y is equal to. And then we go ahead and get rid of the 5. It's times 5, so we divide by 5 on each side. So we're going to end up having y equals 11x over 5 minus 9 over 5. Now, we don't really care about the minus 9 over 5, we simply care about the gradient. So the gradient of that line will be 11 over 5. So that means the gradient that's going to be parallel to that will also have a gradient of 11 over 5. 5 across and 11 up. And so the gradient that's going to be perpendicular to that, again, will be the negative reciprocal. Simply invert the fraction and change the sign. So it will be negative 5 over 11.